really is a lesson that I need to start doing this stuff more in advance before logging on. There we go. Sorry, I thought I was already logged in so that I can access the old comments board. There we go. Now I think, yep, there we go. Let's post a little hello. Hello. Let's also get the word out on Twitter, my favored social media platform here. Let everybody know that the Twitch stream is live. I am live on Twitch. Wi-Fi scanners today. Okay, there we go. Comments are up. Tweet has been sent. Only 7 minutes late today. Not bad. Not good either. But, you know, I've done worse. So, yeah. So, let me bring back up the presentation from last week. You know, if for those of you that joined last week, you may remember I went, whatever it was, a little bit over an hour. Things didn't get to everything that I wanted to talk about relating to Wi-Fi scanning tools. I did get through a little bit, gave a little bit of kind of an example of some of the things I look for in Wi-Fi Explorer, which is my favorite Wi-Fi scanning tool. But didn't really get to go through the use cases, and that's kind of what what I want to go through today, is kind of talk about, you know, how I use. Come on, presentation, let's go. Having a little bit of trouble here. Yeah, I really gotta start preparing better with this stuff, don't I? But yeah, so. Going through today, I want to go through a few of the use cases with Wi-Fi scanners and sort of how I use them. I'm going to try to keep today's stream to more like an hour. That's been my goal, is to try to keep some of these times down. We'll see. Those of you that have joined me before, or that just know me in real life or from Wi-Fi conferences and such, know that maybe I like to talk too much some of the time. So I'm trying to fix that. Try to keep things a little bit tighter. You know, look, one of the things I always like to say is what people love to do, whatever it is they hate. And talking too much is definitely one of those things with me. Like, you know, I'm a big movie fan, and one of the movies that recently came out on Netflix is The Irishman, directed by Martin Scorsese, you know, legendary film director, a bunch of great actors in it and such. I still haven't watched the thing because I heard it's 3.5 hours. And, you know, I tend to like my movies tight. I you know, prefer 2 hours, maybe a little bit more, maybe a little bit less for movies. But it is one of those things where we do whatever it is we hate, because I definitely also tend to not know how to cut, not know how to keep things short. But I'm going to try to do that today. So after that bloviating intro, let's get into it. So again, this is Wi-Fi Streaming with Ben Miller. I do this on Wednesdays, 10 a.m. Pacific time. That is 6 p.m. in the United Kingdom. That is 8 p.m. in Helsinki, Finland, home of many very fine Wi-Fi professionals. Hopefully some of you are getting a chance to stream along with me. And you know, thus far I haven't done a great job of making the of making the whole thing kind of interactive, but that's kind of my goal. Is for those of you that are joining along live, if you want to use the chat area, I can. Well, actually, am I able to see the chat messages? Maybe I'm not at the moment. Let's see here. give me, yeah, it looks like, so I have a second computer that allows me to kind of see everybody else's chat messages. And I got to log in on that. Take me just a second. Sorry about the delay yet again here. I really got to tighten this up, don't I? There we go. Now I'm able to see the stuff I wanted to see. So yeah, so the point is, if you have comments, etc., that's kind of what the chat area is for. Want to make this as interactive as possible, and hopefully educational and such. So if you do have comments, questions, criticisms, etc., feel free to share. So again, for this week, we are talking about Wi-Fi scanners. That's what we talked about last week. But it's going to be the usage of Wi-Fi scanners, kind of where those things can be used. Quick introduction for the show, because I realize there may be some folks that are joining or watching for the first time. My name is Ben Miller. This is not a picture of me. This is just a beautiful default Apple Keynote picture that I really like. Makes me feel good every time I see it. Plus the background there. I can't tell for sure, but the little mountainous area with some buildings might be Southern California. I am located in Los Angeles. Not sure if that's Southern California, but it might be. And so that's what I use as my picture. You can already see me on the Twitch stream. That's why I don't have my picture on this page. If you want to keep in touch, Ben_Sniff Wi-Fi, of course, is my name on Twitch. And then on Twitter, it's just a straight up Ben Miller, at Ben Miller on Twitter. I also have a blog. Just posted a blog post today. We're going to cover the topic that I talked about in the blog post. What I talked about today in the blog post is what I like to refer to as wasted Wi-Fi. Here's how I define wasted Wi-Fi. Wasted Wi-Fi means Wi-Fi that performs worse than it should based on your environment. So remove the variable of your Wi-Fi design, like where you placed access points, what model of AP you're using, what types of antennas you're using. Remove the variable of the types of client devices you have and the building construction, or if it's an outdoor area, the geography of the outdoor area. Remove all of those physical variables, and you just kind of step back and ask yourself, is this network performing as well as it should given my physical environment? So given where my APs, antennas, types of client devices I have, number of clients, geography, physical construction of the building, etc., given all those things, is my Wi-Fi performing as well as it should? If it's not, then you've got wasted Wi-Fi. And I've noticed it's kind of a significant issue that there's a lot of environments where I take a look at the environment, like, how many APs, where you've placed the APs, what your user density is, etc. And I say, this Wi-Fi really should be working, or it should be working better, or it should be more resilient when crowds are using it, or, when usage becomes really high, but it's not working as well. And so, what that basically means is that there's some type of configuration issue. That something in the configuration of your access points, controllers, your Wi-Fi infrastructure basically is kind of holding you back, is making the Wi-Fi perform not as good as it should be. And the good thing about wasted Wi-Fi is because it's a configuration issue, it's a low-cost fix. You don't have to buy new equipment, contact people to install your network, etc. It's just, you do your research, you get to the configuration interface, you adjust a few little settings, and that's that. Now, the downside, I'm making it sound simpler than it really is, of course. The tricky part of that is, as I say in the blog post, it takes guts. I mentioned I worked for about a year at a university Wi-Fi deployment, relatively large university. Again, we'd maybe get a neighborhood of 60,000 people, or 60,000 Wi-Fi devices, I should say, on a busy day. And, it's harrowing. When you're making a change to a network that large, it's like, geez, even if I think I'm solving one problem, am I engaging in a game of Wi-Fi whack-a-mole where bang, solve that one problem and a bunch of other problems pop up. So it's a harrowing thing to try to change large-scale enterprise configs, but it can solve a wasted Wi-Fi problem. So I'll cover wasted Wi-Fi and talk more about that on the Twitch stream. If you want to check it out on the blog, again, sniffwifi.com is the place to go today. And yeah, if you're wondering about my background, been in Wi-Fi a long time. Currently doing contracting. We'll have to see. Yeah. Currently, that's what I'm doing, is contracting. So let's get into it. Let's talk about scanner usage. Quick recap of what we talked about last week. Last week, we talked about kind of where Wi-Fi scanners fit in the broader spectrum of Wi-Fi tools. Wi-Fi scanners allow you to get access point information. The key thing is you can get access point information, number one, kind of from a client device's location. And then number two, you can get access point information using the client device's radio. That can be very, very important. For example, if you want to get information about a Wi-Fi environment, about access points that are in your area and how well they're covering your area, and you're using a Mac, you can use that Wi-Fi Explorer application that you saw me showing earlier on. If you are supporting iPhones or iPads, there's an application called Airport Utility that gives you scanner information. That is a Wi-Fi scanner. Airport Utility is completely free, actually. I mentioned Wi-Fi Explorer costs whatever it is. I think $15 or $20 for the base version and $100 for the pro version. If you have to support a large-scale enterprise of any kind, I certainly recommend the pro version. It has some features built in. I talked about those last week that are nice for larger scale stuff. Airport Utility, however, is free. If you're supporting Android devices, there's free applications there. For Android, probably my favorite one is called Aruba Utilities. That's the one that I have used over the years when I've had to support Android devices or do testing with Android devices. So Aruba Utilities is one to look for there. There's other free scanner applications, but at least my preference is Aruba Utilities. And then for and by the way, you don't have to be in Aruba environment to use Aruba Utilities. There are some features of Aruba Utilities that you can only use on an Aruba environment, but if you're just looking for basic Wi-Fi scanning, if you're just looking for that access point information, you can use Aruba Utilities with a Cisco infrastructure, with an Extreme infrastructure, with a Mist infrastructure, Ruckus, whatever you've got, basically. And then for Windows, I would say that among the free utilities, the one I like best is Acrylic Wi-Fi. Acrylic Wi-Fi is a somewhat similar situation to Wi-Fi Explorer. Again, for Macs, I really like Wi-Fi Explorer. Whoops, I'm writing that right over my name. So Mac, Wi-Fi Explorer. So Acrylic Wi-Fi is very similar to Wi-Fi Explorer in that there is a pro version, and that if you're having to support a large enterprise, I would certainly recommend the pro version. The pro version includes allowing you to set aliases and annotations and doing a few things that can be useful when you're having to support a very large scale environment. Yeah, and Slim mentioning some of these free tools are really nice. Absolutely. So that was from the chat area there where I talk about Slim. Slim to None being the actual screen name there. So we kind of talked about that last week, kind of where Wi-Fi scanners fit. We talked about some of the other Wi-Fi tools out there and what those tools do. I don't want to rehash that too much. That was my little placeholder page, and talked about kind of why I like Wi-Fi scanners. I can get information about my connection, and I can get information about CCI, co-channel interference. That's the basic thing there. I'm getting signal strength measured from my device, from a real-world device. I'm getting all of the information that comes from the access point beacon frames. It's one of the things that I really like about Wi-Fi Explorer and why I recommend it so much for folks who use Macs. In Wi-Fi Explorer, here I have my network selected, but if you look down below, I can get kind of some nice information from the beacon. I can get sort of more accessible information that I would say, oh, whoops, sorry, I forgot to put Wi-Fi Explorer back up on the screen. There's Wi-Fi Explorer. So there's me clicking on the network that I'm connected to. Hopefully you can tell there the network's bolded. Notice how that's bolded a little bit because that's showing me that's the network I'm connected to. So I kind of get this more accessible information. Oh, here's the speed I'm supporting. Here's the type of encryption. Here's the type of security. Here's the channel width, etc. Gives me a little signal strength reading with a history of signal strength. That can be very nice for surveying, if you want to walk around and find out information. I'm not currently tied into a spectrum analyzer, but it does show me an approximation of how the spectrum might look. But yeah, it's this advanced details screen that I really like for the beacon information. It basically breaks down the entire beacon. And the beacon from the access point tells you things like what speeds are supported. Speeds are commonly called data rates. It tells you what channel you are on. Tells you the channel width that is currently being used. Whoops, there's the channel width. Tells you how many MIMO streams, how many spatial streams are being used. Tells you the security. So a lot of that stuff does get summarized in other areas of Wi-Fi Explorer, but if you're the type of person who really likes to get into the nitty-gritty, that can be a very nice part of these tools. So we're only 22 minutes in. Time to get to the point here. The point of today is to talk about usage of the Wi-Fi scanner. So how am I going to use a Wi-Fi scanner? I'm going to just kind of talk about the three ways where I use Wi-Fi scanners. I don't know, maybe there's some stuff out there or some usage cases of Wi-Fi scanners that I'm not familiar with that other people have. But these are kind of the three ways for me. Number one, surveying. So what I mean by surveying, sometimes surveying is called design. What I mean by surveying or design is taking an environment that does not yet have Wi-Fi, or taking a Wi-Fi environment that does have Wi-Fi but is in need of an upgrade or is due for an upgrade, and figuring out optimal locations before installing your wireless LAN infrastructure. So before you go and install access points, antennas, run the cable lines, whatever you're going to do, you go and you survey the area or you design the area. Different people call it different things to determine where you want to place your access points. So that's one place where I use Wi-Fi scanners, is if I have to do surveying. Second is for what I like to call preventative validations. So what I mean by that is you're in an environment that is not in need of a new deployment. You already have Wi-Fi. You're not doing a full upgrade of the environment. You're not on your whatever every 3 or 5 or 10, however many years Wi-Fi update schedule, or you're not, upgrading to a new 802.11 standard or something like that. But what I mean by a preventative validation, gosh, and I forgot to, sorry about that. My lack of Twitch skills is showing here. Apologies. So again, these are the usage cases. Number one, surveying, sometimes called design. Number two is what I call preventative validation. And again, what I mean by a preventative validation is a situation where it's not a full survey or a full design, right? The Wi-Fi is already deployed. You're not doing an upgrade. You're not ripping out the old access points and putting in new access points that are a different vendor or that are a new standard or something like that. you're sort of trying to keep the existing infrastructure, but you are trying to be a little proactive. You're trying to be a little bit preventative, and you're going to validate the Wi-Fi environment for any number of reasons. Maybe it could be that there's an event that's about to happen, and you want to make sure the event goes well. Or maybe there's signs that your Wi-Fi may not be that great, and you're worried that maybe the Wi-Fi is a problem, but people just haven't told you about it. Users haven't told you about it. For example, one of the things I mentioned in the blog, this just happened to me a couple weeks ago, is I was talking to a longtime friend. This was actually the person who got me into Wi-Fi many, many, many years ago. And he was telling me about going to one of the local casinos here in Southern California, to the San Manuel Casino. And, my friend knows that I still work in Wi-Fi. And so my friend was like, the San Manuel Casino Wi-Fi is so terrible. He's like, there was no cell reception inside the casino. And, so he wanted to be able to use the Wi-Fi, but the Wi-Fi, in his words, was just unusable. And, he said that it's a known thing, that, he knows that the San Manuel Wi-Fi is bad. Everybody else that, he goes gambling with or whatever knows it's bad. He even said he'll sometimes drive further to a different casino, to the Pachanga Casino, to avoid San Manuel, just because of how frustrating the Wi-Fi experience can be there. And he was saying, it's been going on for years. Everybody knows about it, in his words. But I asked him, do you ever tell anyone? Do you ever open up a ticket? Whatever, even just tell a pit boss, hey, can you check on the Wi-Fi? And he said, no. He's like, I don't want to deal with tech support. My friend works in tech. That's how he got me into Wi-Fi many, many years ago. And so he knows what tech support is like. So he was saying, no, he's at San Manuel for a few hours. He doesn't want to spend his time talking to someone who works in tech support. And my friend knows how a lot of tech support folks are. They're always kind of blaming the user. Oh, let's check your device. What's wrong with your device? Well, we don't have any other Wi-Fi complaints. It must be your device. And so it's a situation where at San Manuel, the Wi-Fi apparently is terrible, but they have no idea, that San Manuel hasn't been told that the Wi-Fi is bad. I would be willing to wager that if you went to San Manuel's NOC and you looked at their monitoring tools, now some monitoring tools are better than others. So it may be a case where San Manuel just doesn't have modern monitoring tools, so they truly have no idea what's going on their network. But I would assume that San Manuel is a big enough deployment where they probably have some type of way to monitor heck, even if you're not going to buy, sort of a dedicated monitoring solution. Like the one that we used at USC, which I think I've mentioned before, that I really like is from Niansa. It's called Voyance. That was kind of the number one monitoring tool that I like to use when I was working at USC. I thought it did a good job of kind of giving you enough detail about the client experience that it was helpful in trying to figure out if you had problems that just weren't being reported yet. But even if you don't have one of those fancy tools, you can still look in the CLI of your access points or of your controllers. You can look in the basic management interface sometime, and you can get a general idea. If you know that on an average night there's, at a given time on an average night that there's 2,000 people that are on your casino floor, and if you look at the guest Wi-Fi and you're only seeing 100 connections, and if you've been on your casino floor and you know that the cellular service is a little bit spotty in certain areas, that's a major red flag. Or if you see, let's say see 1,000 connections, but you're only seeing, less than a kilobit per second of data per user, then even if you don't have problems reported, even if you're not really doing troubleshooting, you still may want to go out and do what I like to call a preventative validation, where it's not in response to a troubleshooting ticket. It's not a full on-site survey like that you would do as part of an upgrade or as part of a new deployment, but you're just going out there to try to make sure your Wi-Fi is set up correctly, not in response to anything necessarily. And then the third usage of a Wi-Fi scanner is just troubleshooting. So the difference there between number 2 and number 3 is number 2 is in a response to something. So there's a trouble ticket open that says the Wi-Fi stinks on the San Manuel casino floor, whatever it is. And so you go in there and you try to figure out what was going on. So those are kind of the three big cases for where I use Wi-Fi Explorer, especially if I'm trying to support Macs, or if I'm trying to support devices of other operating systems. I might use that airport utility for Mac OS, or I might use Aruba utilities for Android, or I might use Acrylic Wi-Fi for Windows. Those are kind of the three use cases. So let's go through each one. So let's start with the surveying design. Where does the Wi-Fi scanner kind of fit within the surveying or design? And so this is what I typically try to do. This is my methodology, so to speak, that I typically try to use if I'm on a project where we're doing a full-on survey. So by full-on survey, again, I'm saying it's a building that doesn't have any Wi-Fi, or a location that doesn't have any Wi-Fi and we're trying to add it. Or it's a building or it's a location where there's existing Wi-Fi, but we're looking to do some type of upgrade. Okay. Slim to None also asked the question, is there a way to embed annotations or aliases so that other devices can see that information? And Slim, the answer there, as far as I know, is no. The one thing I know that you can do if you have multiple Wi-Fi Explorers, let me bring this up on the old screen here so you all can see it. It's a little bit tricky to make it so you can see this part of it. But what you can do is you can export your annotations to a CSV file and then import that to another instance you might have of Wi-Fi Explorer. So if you do have, multiple devices that people in your organization are using and running Wi-Fi Explorer on, they can essentially share aliases. But what you don't have the ability to do is just, kind of put in an alias or an annotation. Let's say, let's say you have a Cisco installation. You can't just name the access point in your Cisco controller or in your, whatever Cisco management interface you're using, and then have Wi-Fi Explorer pick that up automatically. At least to my knowledge, if Adrian Granados is the maker of Wi-Fi Explorer. Let's see, I think it says it up here. Yeah, you can see it right there. Actually, probably shouldn't be. There it is, but you see there, Adrian Granados. So if, Adrian Granados might be able to tell me differently, but at least as far as I know, you don't have the ability to just, yeah, exactly. Now look, that part is a pain, what Slim's mentioning there. Because look, that was one of the things that I dealt with at USC was, I think by the time I was let go from there, I think we had maybe 8,000 access points, maybe a few more, maybe a few less, but it was somewhere around 8,000 access points. And so that was just a lot of access points to get installed. And I wanted to have all of those access points in Wi-Fi Explorer Pro so that if I get to number 3, the third thing I mentioned was troubleshooting. If I get to the troubleshooting part, ticket is opened, whatever, I hear about a complaint from someone, I wanted to be able to just go right to that location, go right to that outdoor area, or right to that building and do my troubleshooting work in Wi-Fi Explorer Pro. I didn't want to have to import all of the access point names and cross-reference that with floor plans and such, before I would go out and do troubleshooting. And so it was a very time-consuming process. I don't even know how many hours I spent exporting CSV file, not even a CSV file, but running commands, exporting the output of those commands, taking that command output and putting it in a spreadsheet, and then slimming the spreadsheet down so that you may remember from last week, those of you that came along, for these CSV files, it just shows the first column is the BSS ID and the second column is the annotation. So to get those exports from the CLI to be a spreadsheet that just shows BSS ID and then the access point's name, that took hours upon hours upon hours to do. I don't exactly know how many hours I spent on that, to be honest with you, because it was a long time that I spent getting Wi-Fi Explorer to the point that I and the other folks on the network engineer on the wireless side of the network engineering team at USC could use Wi-Fi Explorer and use it efficiently. So that part is a frustration, Slim. I wish I had a better answer for you. You know, if you know of a way to just export your entire infrastructure's BSS IDs and AP names into a CSV file, then you can import into Wi-Fi Explorer Pro pretty easily. And look, you know, USC is a very large organization, but we probably had a grand total of 15 people at the entire university that would ever use Wi-Fi Explorer Pro. So that's counting the field services guys and I think there was one gal at the end who respond to kind of the trouble tickets initially, the wireless team within the network engineering group that would respond to escalated tickets, including all of the people that might possibly need a Wi-Fi scanner. I think there were only maybe 15 people at the most. So if, you know, once I had that spreadsheet, then it was pretty simple. It's just, you know, distribute the spreadsheet to 15 people, tell them, hey, click file, click annotations, click import from CSV, put this in your Wi-Fi Explorer Pro, end of story. You know, so it wasn't that bad. It was just getting the spreadsheet was the tricky part. I got a message here from Papa Georgity, certain person I know from Twitter, obviously. And the question there is a custom column setup. The column setup that I've used is what you're seeing here. The key information that I want from Wi-Fi Explorer Pro is I want the BSS IDs, I want the annotations, I want the signal strength, I want the channel, and I want the channel width. So those are kind of the 5 things I'm looking for. That is 5, right? Yeah. 5 things I'm looking for when I know. Sorry. I've never actually said the Twitter name out loud. That's the problem here. So yeah, my apologies there. What can I say? But yeah, Alan is his name, of course. I shouldn't say of course, maybe not all of you follow him on Twitter. But Papa Jordy. There we go, Papa Jordy. Oh, that's right. So in the United States here, JOR would probably be more likely used rather than GER. Sorry, Alan. But yeah, so in any case, that's at least the way I use Wi-Fi Explorer is I kind of use these default columns, and I'll talk about it as I go through the use cases. But I tend to have Wi-Fi Explorer, and then I also tend to have a floor plan. And if I'm doing number 2 or 3, if I'm doing the validation prevention or if I'm doing the troubleshooting, then I make sure that floor plan has my AP locations. And if possible, not only do I have the AP locations, but I try to get information about the cable runs. That was one thing I did when I was at the university was as much as possible when I would embark on anything that might potentially require a change, right? Troubleshooting, you might have to change something. Of course, the preventative stuff, you're looking to change something. If I was embarking upon anything that might require a change, I always tried to go to what we called the communications infrastructure team and kind of ask them, hey, for this building or for this location, do you all have a schematic of kind of where the cable drops are or where the cable runs are? Or can you give me any info on where you might be able to drop cable? Because, what I found from my early experience working at the university was I would go to a location, I would say, okay, we have Wi-Fi problems. I see what's going on based on the infrastructure we have. Here's some changes I would recommend. And then I would get that floor plan with kind of the different or with the additional AP locations kind of spat back at me, and it would. And I would kind of be told, well, we're not going to be able to run cable here for another 3 months because we have to go over a doorway or something like that. I don't know. And so to try to make things as simple as possible for everyone and get problems solved as quickly as possible, I like to have those cable runs or cabling information if possible before I go out. So for me, it's usually Wi-Fi Explorer looking like this, along with a floor plan, preferably with AP locations, preferably with information about cable runs. That's what I tend to go out there and do. But yeah, so let me get back here to the old... there we go. So yeah, let's start with kind of the surveying part. And look, I had to address kind of what one might call the elephant in the room before going in with this is you're not going to see me talking about using site survey applications for any of these activities. And look, it's always a little bit of a tricky thing. I've over the years sometimes had people who work for or who are involved with site survey applications really get upset with me or dislike things that I say. But I think sometimes that's a miscommunication. Site survey applications, in my eyes, are extremely valuable for documentation. If I as a network admin or a person who works for a VAR or a person who works for a vendor need to document something for management or for people who may be less familiar with the technological details of Wi-Fi and such, whatever it is, if I need to document something, I find that these site survey applications, Ekahau, Site Survey Pro definitely being the biggest one, the biggest meaning kind of most widely used. I definitely find that there's a lot of value in having site survey applications to do a predictive heat map or do a live heat map or whatever it is for documentation. But when it comes to the actual problem solving, when it comes to the actual survey of determining where I want my APs, or when it comes to the actual preventative validation of trying to figure out if I need to make a change because there's an event coming or because I think there's a problem that just hasn't been reported to me, or when I need to do troubleshooting and when I need to, solve the user's problem. For all of these cases, getting the actual problem solved to me is not necessarily best done with the site survey application. To me, the site survey application is a great way to kind of document what you've done. So it's like from the technological perspective, I do my survey kind of with tools that can show me more real information, and then I can document what I've done using the site survey application and kind of create the heat maps and the other documentation that is a little bit more accessible to management or to someone who may not be as hardcore into Wi-Fi. That's at least the way I use those tools. So I realize that's a bit of a controversial issue. Like a couple of months ago, I took an Ekahau course, ECSE Design Ekahau Certified Solutions Engineer or whatever what the ECSE certification is. I took a course, and the way that course was presented was totally different than what I'm saying. The way that course was presented was, well, Ekahau's the tool you use to survey, you use to validate, you use to troubleshoot. It's just, I see things a little bit differently than that because, again, I like having kind of the real information. And that's the whole key there. Wi-Fi scanners allow me to get real information for any operating system, for any type of device. For any type of device, there's a free or a low-cost Wi-Fi scanner that can be installed on that device to get me real information. That's not necessarily true with site survey applications. And things have gotten a lot better with site survey applications. Now there's a ton of cases where you can use the internal, a real Wi-Fi adapter to create heat maps and such in Ekahau. So I don't want to say, you can't use Ekahau for these things, or you can't use other site survey applications for these things, but certainly, at least for me, it's more of a documentation tool. So setting that aside, because I realize that's a bit of an elephant in the room normally. You say, well, how are you going to survey? One of the first things people say is, oh, you get out Ekahau, you do this or that. So here's at least kind of the way that I do it. And notice the Wi-Fi scanner really only comes in towards the end. If I'm doing a survey, number one is I'm getting a ton of information. I'm getting as much information as I can. I want to have a floor plan. I want to know the building materials. This may mean measuring. This may mean referring to documentation about what types of building materials are, and kind of having that knowledge. Oh, here's how much loss you typically get through, 1.25 inches of sheetrock or whatever it is. It might be meeting with people. It might be talking with people. I've had to do this before, in fact, with the example I'm going to show you with this project here. A big part of this project surveying was meeting with the contractors who were, so this was a big renovation. So what you're seeing here is the green dots are the existing access points, but all of the little desks and meeting rooms and conference rooms and such, those were undergoing a huge renovation. And so I did not have the ability to kind of physically survey this environment. So I had meetings with the contractors who were going to build this stuff to try to get an idea of what the environment was going to look like. Are there any partitions here? Is this really as open as it looks? What types of materials are being used? If there are walls and partitions and glass and whatever. So it may involve a lot of kind of meetings. And then, finding out, okay, what model of AP or types of antennas are we planning to be used? Again, I go back to the cabling thing. Working at USC was a real eye-opener for me, because the cabling was the key. One of my best friends in the world of Wi-Fi is a guy by the name of G.T. Hill. He's been in the Wi-Fi game for a long time. I know he's with Extreme Networks now, and very, very, insightful Wi-Fi guy, in my opinion. And years ago, like over 10 years ago, he told me, the worst part of wireless is running all the wires. And I kind of chuckled at it, but at the time, GT was doing a bunch of side jobs where he had to install Wi-Fi at motels and kind of independently owned hotels, kind of smaller environments, independently owned environments, budget conscious environments. And so I was like, yeah, I guess that's a clever thing to say. Worst part of wireless is running the wires. But, he's working at these little small environments. So, that might be different than larger organizations. And so when I started doing a little bit of consulting on my own, I found that usually we could run cable where we wanted to. But then when I worked at USC for the year, we could not run cable where we wanted to. It's an educational institution. USC, I think, is, I'm an alumni, so I'm biased, but I think it's a very prestigious institution. It's definitely a very expensive institution, but it still is education. It still is a nonprofit, and so they still are very budget conscious with anything IT related. And yeah, the idea that, we can just run a cable here to mount a new access point or move an access point, that was not happening. There were a ton of cases where it's like, okay, let's try to do this here, and you get word back, no. Find out another way to do it. We're not going to spend all this money and all this time for for the people on staff to run a cable to this location. Here are 2 or 3 other options of where you can try to run a cable and mount an AP. If you have a coverage problem somewhere. And so yeah, number 3 definitely became an eye-opener after working at USC. And then obviously the budget, for the one I'm showing you here, this one, if you, I don't know how well you can kind of see the square footage on there, but if you look at the actual square footage, you may not necessarily need quite the number of access points that are showing on there. My first draft actually had fewer. Obviously, though, you can see there's a lot of desks. And, the thing about it is, I kind of touched on this last week, I find a lot of times in Wi-Fi, the numbers people put on clients per AP are a little bit lower than they have to be. I see people say, oh, we want to keep it to 40 clients, 50 clients, whatever per access point radio. I find, if you have a network that's fairly well designed and that has the appropriate configurations and that, doesn't have a ton of interference from outside sources. And for this case, this is an office building that's in a suburban location. This is not like some multi-tenant situation. This company owns this entire office building, so they don't have to worry about interference from other environments, from other Wi-Fi. And so for a case like this, you can probably do more like, you can definitely do over 100 clients per APs without a big problem. Maybe even 120, 150. And so when I kind of did my first draft of this thing, I had fewer. So you see the little blue dots. The little blue dots are kind of where the APs would go. Or if you don't see an arrow, that means the AP is going to stay there. And so initially I had fewer APs, but then I was told by the person who brought me in to work on the project, she was like, are you sure you need this? And I told her, I was like, well, I'm approaching this from, we want to give you all, reliable Wi-Fi, redundant Wi-Fi, etc. But I'm also approaching this from the point of view of, we don't want to have any kind of like excessive spending. And she immediately was like, don't worry about that. She was like, the executive, it was actually the owner of the company. It's a very, very large company. The owner of the company, had some visibility into this Wi-Fi upgrade project, and he had been very dissatisfied with the Wi-Fi at this office. He had heard from his executives that the Wi-Fi wasn't very good at this office, and so the owner of the company was like, do whatever it takes, spare no expense to upgrade this office and a few of the other offices that I worked on for this company. And so budget may not be a concern, but budget may also be a concern. So again, kind of a major part of the site surveying process is just, at least to me, just gathering information. Just, what are those building materials? What APs can I use? Where can I run cables for these APs? Is there a budget I need to stay under, etc.? Then from there, things can diverge a little bit. So what I say then is choose the AP locations once you have that information. That sometimes is where the site survey application may come in. You may do sort of a predictive heat map as a way of choosing the AP locations. But honestly, it's like your AP locations should not be based on a heat map. It's kind of putting the cart before the horse. Your heat map should be based on the AP locations that you chose. So, for example, you want to choose locations that are going to give you a good enough signal everywhere, of course, going to be able to handle the client density, but you also want to choose AP locations that make sense for the environment. Getting back to my example here, we got this is kind of a what they call it, MPR, I think it was, multi-purpose room. It could be used for learning. It could be used for presentations. It could be used for meetings. And these were very, very thin walls. What you kind of see around here, these were very thin walls. They allowed Wi-Fi to go in and out pretty easily. And so we didn't really need to have an access point inside that room. In fact, given the mounting of the access point, just because the ceiling of this little auditorium was a lot more difficult to access and a lot kind of trickier, we really, could have been a little bit easier to avoid having the access point inside this room. But it's an important location. It's a location where a lot of people are going to be, and so we wanted to make sure that we had an access point inside this room to make it so that we had a good Wi-Fi for the people during these potentially important events. Another example here is trying to get access points away from these stairwells. At this location, it's kind of what you're seeing there, that octagonal shape. That's a big kind of open atrium. There's a few different floors, I think 3 floors in this building, but it's this big open space. And I knew that if we had an access point kind of right near that open space, that the Wi-Fi signal would do a lot of bleeding between floors and potentially present a hidden node problem. Hidden node is where you have 2 or more devices, and I'll put this on here just for those that may not know. The hidden node is where you have 2 or more devices that can interfere with one another, but that cannot hear each other. And one way that you can give yourself a pretty darn good chance of having a hidden node problem is by having access points that provide strong coverage on multiple floors. This, I believe, is the 2nd floor, if I'm remembering correctly. And so I didn't want to have some client device over here on the 2nd floor, a laptop at someone's desk on the 2nd floor, and then a laptop on the 1st floor down below, both connecting to this same access point. There would be an excellent chance that those 2 devices cannot hear each other. And if 2 devices are connected to the same access point, they can definitely interfere with one another. And so, even though I could get coverage everywhere by keeping these access points close to the atriums, to avoid the hidden node problems, I recommended that they, move the APs, get them over towards the same thing, getting APs towards the edges in lower floors, 1st floor, 2nd floor, so that if there is any kind of interference coming from outside of the building, that there's an AP that's very near to where the user is. If there is a user here who has a laptop relatively close to an exterior wall, that user has an AP relatively close to them, so that if there's interference coming from the outside, hopefully that interference won't be as big of a problem. It won't cause a lot of noise or anything like that. So again, when I say choose the AP locations, it's fine to use a predictive software application. It's fine to use a site survey tool to do a predictive heat map, but I would just say don't put the cart before the horse. It's like, choose your AP locations first, then create the heat map. Don't use the heat map to choose your AP locations. You know how many APs you need to get coverage everywhere without looking at a predictive site survey application. Whether you have a high enough number of APs to handle your typical client density without looking at a site survey application. So you can choose your number of APs and approximate location of your APs without using the site survey application. The site survey application, at least in my view, is something you bring in afterwards for documentation purposes, so that you can get the nice, red and orange and green heat map showing you, good signal, bad signal, whatever it is, once you've chosen the AP locations. It's a little bit trickier if you're one of those folks that maybe has a little bit less experience in Wi-Fi, then sometimes the site survey application can help you. But gosh, this is the thing I mentioned, a couple months ago, I took that Ekahau class, and one of the things that's done in that Ekahau class is you're given a floor plan of a medical office. You're told to choose AP locations without Ekahau, and then you're told to choose locations with Ekahau and kind of doing the heat map and everything. And the class I took is an entry-level class. It's Ekahau's entry-level class. The early part of the class is going through some basic stuff about Wi-Fi. It's actually a pretty good class. If you don't know that much about Wi-Fi, I'd say it's a decent enough class to attend. But I found, it was a 12-person, there were 12 of us that were in the class, and I would say all 12, or maybe 11 out of the 12 designs that were done before touching Ekahau were perfectly fine. There were some little things, most of the people in that class were relatively inexperienced when it comes to Wi-Fi. So maybe there were some little things. Maybe people didn't pay that close attention to the fact that you probably want to keep an AP inside of a big important room or a meeting room, or you want to keep an AP near VIPs, near like a prominent doctor's office or in the doctor's office, because, you want to make sure your VIPs are doing well, or you want to keep APs near exterior walls if you're in an environment where interference from outside of the building may be a problem. So maybe there were a few of those sort of tricks of the trade that some of the people missed, but the designs that people made before Ekahau were no worse than the designs people made after Ekahau. It was, it doesn't take, it's not that complicated to choose AP locations. It's just the keys. You need to know the number. You need to know where the cables can be run, etc. The other thing that I like to do, I try typically to keep things as symmetrical as possible. And, what I mean by that, for example, is, keeping the APs the same distance away from the outside walls as you're seeing here. Sometimes trying to keep the APs the same distance away from each other. I just find that keeping things as symmetrical as possible can really help out when you have to do any kind of maintenance or troubleshooting of the network. It helps kind of where APs are supposed to be. It makes it just easier to remember things so that you're not always looking up everything from scratch whenever you have any type of issue or any type of validation that you want to do. So once you've done that, you choose the AP locations. Of course, as much as possible, you try to oversee the install, or, if you're very trusting of the people who are going to do the install, then maybe you don't have to do that. I've been in both situations. I've been in cases where, we've had issues where APs don't get installed in the right locations or don't get mounted in the way we're hoping they would, where, I have to really help oversee the install. And then I've been, like, for example, the floor plan I was just showing you, that was from a company where I had done work with them before. That company uses the same contractors for a lot of their AP installations, had worked with those contractors before. Those contractors had done great work. So I wasn't on site at all when they were doing any of the installations, because for them, I could kind of trust them. So then once you've done that, at least now this is the way I do the surveying, at least, and I know not everyone may do it this way, but the way I do it is once the install is done, then I look at the floor plan, or I look at, the geography of the environment or whatever it is, and I just try to choose a few surveying locations so that I can take one or more Wi-Fi scanners to those locations to validate that the Wi-Fi looks like it's going to be as good as I intended it to be. So, to be honest with you, I don't remember all of the locations I went to. That was one of the reasons why I was late starting class, as I was looking through, trying to see if I had the document where I kind of scribbled down notes of where I did my surveying locations from. But if I'm remembering correctly, I know I was at least inside of this room, for example. So I know I was inside of this room here in the upper left at least once. I know that I went inside all of the conference rooms and kind of those meeting rooms and such. I know I went inside the men's restroom. I was kind of told that there were some people that were in management positions at this office that weren't very happy with the Wi-Fi reception in the restrooms. So I definitely went inside the restroom to kind of make sure that these APs that we had closer to the restrooms were doing their job. And I know I went to, the stairway. I knew people would be likely walking up and down the stairs, wanting to maintain phone calls or whatever it is they were doing. And then I chose a couple of locations, maybe locations in walkways, maybe a few locations by desks that were a little bit further away from APs, or locations where I was worried about co-channel interference, where I might say, well, maybe in this location, it's possible I could get, signal from 4 APs on this side and maybe 1 or 2, maybe even more than 2 on the other side. So let me make sure these APs are using different channels, that they're not causing CCI with one another. So I kind of looked at the floor plan, chose some surveying locations, and then I just go to each location and I pull up the Wi-Fi scanner. And, you know, again, it depends on the device. For this particular project, I know that I was told that that people have wired internet connections at their desks. So smartphones were a big thing they were focused on. So I had one Android smartphone and one iPhone. I chose a slightly older model of the iPhone. This was actually a couple years ago, but I think the latest iPhone at the time was the iPhone 10, the original iPhone X, and I was using like an iPhone 6S to do the surveying, so that I had a little bit kind of older model of iPhone, just in case the iPhone wasn't as robust as some of the people had older iPhones that weren't as robust. I also took a laptop with me. I took a MacBook with me. It was a mixed environment. There were definitely some people that had Macs and some people that had Windows devices. But in talking to the folks who are the network engineering team at this organization, they told me that that the software developers, that this is a company that has a software product, that a lot of the software developers use Macs, and that the software developers do like to go mobile, that a lot of times they like to get away from their desk while they're working on code or whatever it is. And so I also use Macs. And again, look, the reality is you're not going to be able to use every device with a Wi-Fi scanner, but being able to use multiple devices, just, going to a survey location, sitting down at a desk, pulling up the Android phone, taking a scan, pulling up the iPhone, taking a scan, pulling up the MacBook, taking a scan, recording that information. What I do is I'll just note on my floor plan, okay, this is floor 2, survey location number 6. I'll kind of note the screenshots, or I'll note the output file that I get from my Wi-Fi scanners, and I'll say, okay, this was from location 2, this is floor 2, location 6, and that way I'll have the ability to go back and look at things a little bit. That way I'll have the ability to check that. Now, look, if I'm not saying, it's also possible that site survey software can be useful here. The nice thing about site survey software is it allows you to kind of see the full environment. So if I go to a location, this hasn't happened a ton of times, but it can be useful, and it has happened before. If I go to a location and I see it looks like we have a real CCI problem, but if I also know that we have a real CCI problem, but I don't really have the ability to disable a lot of AP radios, my APs are already spread out far enough, or there's already a small enough number of APs given the number, the large number of desks or the large number of people that I have to support. If I think I have a CCI problem and I don't have the ability to disable AP radios, then using a site survey application that can allow you to kind of create those heat maps can be really valuable. Because then you can go into the site survey location and say, okay, what if I were to disable the 5 gigahertz radio on this AP? And the site survey application will kind of show you what that would look like. It'll show you the heat map without showing you any coverage from this AP. And so that way you can hopefully try to tell, is that likely to help me? Is that likely to cause a coverage gap? So site survey applications definitely can have their place in the pre-install surveying process. So yeah, so that's one place where I like to use the Wi-Fi scanners, is when surveying, kind of doing that validation of the survey. For the second activity, if I'm doing the kind of the preventative validation type thing, there's a lot of similarities. I'm still going to look at my floor plan, so one of the examples we had of doing a preventative survey at USC was for a cafeteria area. It was just, given the number of seats and the number of Wi-Fi devices that were connecting in that cafeteria area, the amount of data going through the access points looked very, very low. And so my concern was that people's devices were connecting, but they just weren't getting a very good performance in that cafeteria. And so what I did there was, look at the cafeteria floor plan, look at where the APs are currently located, have one of those conversations. Hey, where can we add APs to this cafeteria if needed? and, kind of look at the floor plan and determine, hey, where can I add APs? Another thing we did here was I did adjust the channel width. In the cafeteria, there weren't a large number of APs, and we had the channel width set to 20 megahertz. And so I adjusted the channel width to 80 megahertz to hopefully give a little bit more bandwidth to the cafeteria. Now, that's where the Wi-Fi scanner can sometimes be a little bit useful. You may kind of want to go to the area to do a little check before you make any of those configuration changes. And in fact, that was one thing I was asked to do when I went to my manager and I said, hey, I'm seeing something odd in this cafeteria. I think maybe we should increase the channel width. The manager said, okay, go to the cafeteria, check the cafeteria out. So I took a Wi-Fi scanner to the cafeteria just to make sure that I wouldn't cause a CCI problem by using an 80 megahertz wide channel in that area. And again, what I like about the Wi-Fi scanner is it's kind of giving me real information about access point signal strength. I can run the Wi-Fi scanner on a Mac and get the real RSSI that my Mac is getting from the nearest access point or from APs that might cause CCI. And so, that was kind of the idea there. And, it mentions there when you're doing a preventative validation, there are other things to look at. One of the things I always used a lot was kind of the controller. I would go into the CLI and try to get information about how many clients are connecting, at what data rates are those clients connecting, how many packets of data are being sent and received. I could refresh the CLI and see, is the number of data packets in a certain session increasing dramatically, or is it a very slow increase indicating that there might be some type of radio frequency interference problem? So that was definitely valuable. The command, and I've mentioned this in other streams, but this one was always such a useful command to me. It was show, and USC is an Aruba environment. And so this is an Aruba command here, but yeah, I would do show AP debug client dash table, table AP dash name, and then the name of the AP. And you do have to be in the controller that's managing the AP to be able to execute this command. So, if you have a multi-controller environment that has clustering, it may be a little bit tricky to just find the proper AP, find the proper controller that's managing your AP. But I would just run this command. I would refresh this command a few times. This would show me all the clients that were connected to a given AP, show me how much data had been sent and how much data had been received by those clients, or I think it was how many packets actually, how many packets had been sent, how many packets had been received by each client in the client's current session. The statistics reset every time the client would disconnect and start a new session with a new access point. It would show me the data rates that the AP was receiving and that the AP was using when transmitting to the clients. So it showed me a lot of great information as well. So you can use some of these kind of centralized tools in addition to a Wi-Fi scanner. But again, the nice thing about the Wi-Fi scanner is this is real info on that sort of AP to client connection. On that downlink connection, what's the signal strength there? What APs are in the area that may cause interference? You're able to kind of get that real information. And so somewhat similar methodology to the surveying, where I start by trying to get a lot of information. I start by sort of trying to look at what's local on site and figure out where I can add APs or move APs before I go out in the field. But again, what I like about the Wi-Fi scanner is being able to go to that location where I think, there might be a problem in the future. I want to survey for something in the future and see, does it look like I might need a new AP? Does it look like maybe wider channels would help? What might be the effect if I have a higher transmit power to try to improve speeds a little bit, or a lower transmit power to try to avoid CCI a little bit? Using a Wi-Fi scanner can be very useful because, again, it kind of gives you that real information. And then for the third and kind of final usage of the Wi-Fi scanner, and again, I would say this is definitely the most common usage, is just for plain old troubleshooting. For this one, typically the Wi-Fi scanner is kind of used earlier in the process. Of course, you find out there's a problem. You try to get some info from the user. I know I was talking in my story about San Manuel Casino out here in Southern California that, sometimes users may not love that. My friend who works in IT was like, I don't want to talk to the tech support people. So gotta be a little bit, you got to be mindful of the user's point of view and not, take too much of their time or bug them too much. But yeah, and it also mentions here, hopefully you're going to solve the problem on the client device. Hopefully you're going to be able to do that. But then, yeah, once you, if you can't solve it on the client device, you might check the controller, you might check some configuration settings, you might check whatever type of monitoring console you have. Again, at USC, that's where we were using the Nyansa product. That's where we were using Voyance. But if you're not able to pinpoint the issue or not able to solve the issue that way, if you want to go on location, if you want to go on location, these are, kind of generally the tools I use. I tend to start with the Wi-Fi scanner because, again, I'm able to get that real information. And I see, Alan's mentioning there in the chat area, if you have proprietary Wi-Fi devices that don't support scanner software, what can you do there? And at least what I have done when you have proprietary devices is, number one, a lot of proprietary devices will at least show you the signal strength from your currently connected AP. And so if you can get your hands on one of those proprietary devices, then you can do a little walking around. And if you have a floor plan with you, I would make major use of my iPad Pro when I would have to do this type of troubleshooting or this type of preventative validation. You can walk around, you can get that proprietary handheld device connected to an access point. You can look at the RSSI that you're getting on that proprietary device, and you can make yourself little notes on your floor plan. Or the way I did it was on my iPad Pro, which had a floor plan on it. I would make little notes about each access point that was in an area. Now, look, if you're doing this in like a basketball arena where one client device might see 25 or 30 access points, it may not be as practical to kind of do a survey for each individual access point in a given location. But if you're doing this type of thing at a hospital, for example, on a given hospital floor in a given location of a hospital, each client device may only see 2 or 3 or 4 access points in a given area. So if you can get the handheld scanner connected to one of the access points, do a little walk around to try to get an idea of what your signal strength is from that first access point, get that client device connected to the second access point, do a little walk around, see what type of signal you're getting from the second access point. A lot of times you can kind of do things that way. And that can definitely be time consuming. Another method you can use, and admittedly I've used this before, is to try to use sort of a separate surveying device. The risk with a separate surveying device is that the proprietary handheld, client device may not see your Wi-Fi environment the same way as your surveying device. So it's like if I'm walking around with my iPad recording signal strength or looking at signal strength using that airport utility, but the little Ticketmaster barcode scanner for a basketball arena it has a different kind of Wi-Fi radio, a different Wi-Fi antenna than my iPad. Is that really doing me much good? Am I really able to tell what the signal strength is? Am I really able to tell if there's co-channel interference by looking at my iPad? So you can kind of use that secondary device. I've had people talk about like calibration. Well, can't you just calibrate? You say, signal strength. And this is especially, I find people talk about the calibration with the Echo House Sidekick. The Echo House Sidekick is this device that that reads signal strength and is supposed to allow you to see RSSI. And the Ekahau Sidekick works with the very popular Ekahau Site Survey software. And so I've had people tell me about that before. Well, they'll calibrate the Sidekick. So they'll take a look at, let's say a little handheld device that's running a medical application in a hospital. They'll see negative 60 dBm. They'll take a look at the Ekahau Sidekick. They'll see negative 55 dBm. And so they'll say, okay, it's a 5 decibel difference. We'll do a 5 decibel offset. So whatever signal strength you get from the Sidekick, reduce it by 5 decibels to account for the difference between the Sidekick and the little handheld device that's running the medical application. The reason why I try to avoid doing the calibration thing is because of differences in antenna, in the physical properties of an antenna. With my Sidekick here, so the Sidekick is kind of this square-shaped thing. If I'm looking at it, kind of a cross-section of it, it kind of looks like a spaceship-looking thing. It has a little piece in the middle there. There's my little piece in the middle. So inside this Sidekick, I don't know, may be an antenna that is, 4 centimeters long. And inside my little device here, this is my device that's running my medical application. Maybe I have a nice ruggedized case over this device here, a little ruggedized case around the edge of this device. Inside this device, there may be an antenna that's only 2 centimeters. And the end result of that is maybe the sort of area of reception. Let's say red here is kind of my area of reception. The area of reception maybe is a little bit larger for the Sidekick. It goes out a little bit further horizontally and maybe a little bit less far vertically. Maybe, I'll do green for the reception for the little handheld device that's running the medical application. There we go. Maybe that one doesn't go out quite as far, but that means that it also has a little bit, there we go. Doesn't go out as far, but maybe it has a little bit more vertical reception. And so then the problem you run into is if you make this 5 decibel calibration, if you say, okay, that makes sense. Maybe there'll be an extra, 5 decibels here compared to, what it would be at the edge of my barcode scanner. That makes sense in one direction. But, if your users use the little handheld device in a different orientation, if they don't always hold it upright, if sometimes they're laying it flat, or if you're walking around with the Sidekick, if the Sidekick is, at one orientation and the typical usage of the client device is a different orientation, then those calibrations may not be consistent. It may be 5 decibels if both the Sidekick and the handheld device are laying flat on your table. But if the Sidekick and the handheld device are upright, maybe it's a 2 decibel difference in signal strength. So that's why I typically try to avoid calibration. That's why I typically try to use a real device whenever possible. It's been a while since I've seen a Wi-Fi client device, even the little proprietary devices, that have no ability to show you RSSI. Like, as long as the client can show me RSSI, my goal during the survey or during the troubleshooting or during the preventative validation is going to be to use that real client device to get that real RSSI info. If you have a case where the device doesn't show you any RSSI, if it has no decibel reading whatsoever, maybe you'd use some other device. But the other part of it is I do want to try to use a device that has as similar an antenna as possible. So if you say to me, okay, I have this little scanner here, and this scanner has no RSSI reading whatsoever, no decibel reading whatsoever, I still might try to use an Android or an Apple smartphone to do my surveying rather than a Sidekick, just because the Android or Apple smartphone might have a smaller antenna, might have a 2 centimeter antenna rather than a 4 centimeter antenna, and it therefore might be more analogous. But yeah, that is it's a tricky situation that Alan's talking about. There may not be any perfect answers to that. That's another thing I always like to mention in my experience when it comes to working on Wi-Fi is I am definitely not what you would call a perfectionist when it comes to a lot of this stuff. Meaning, I'm not a perfectionist when it comes to design. I don't need to have, and you can probably kind of see that based on what I was talking about when I was looking at the floor plan earlier on. I don't need to have access points in some exact perfect location to give me exactly, the overlap or exactly the coverage. If the AP has to be a little bit further in one direction or a little bit further in another direction, that's fine with me. I find you can't really predict the exact usage of a Wi-Fi network anyway. And so even if you say, well, I want a perfect coverage area or a perfect density design based on the expected number of users, it's like in reality, nobody knows exactly how many users are going to connect, exactly how many of those users are going to have one device, two devices, three devices. And so I'm not a big perfectionist when it comes to the design. Same thing when it comes to doing the surveying or the preventative validation or the troubleshooting, that I was just talking about before. It's kind of the same concept there, where if the RSSI is off by a little bit, that's okay. I still would like to use a real device if I can, because those real devices are going to have the real antenna. They're going to have the same length of antenna or same type of antenna as my production devices, as my users' devices. But I tend not to be a big perfectionist. I'm almost at the 90-minute mark. I do want to wrap this up. So much for me keeping these streams to a more reasonable amount of time. But just a note here, there are cases where the Wi-Fi scanner isn't going to solve all your problems. But, this is something that I really learned over the years, is that a huge percentage of surveying, of preventative validation, of troubleshooting, that at least of the on-site portion of those things, a huge percentage of that really only does require the Wi-Fi scanner. You may use the site survey software to get those heat maps for documentation, or so that you can kind of see the forest for the trees a little bit. You may use a protocol analyzer, spectrum analyzer, or other troubleshooting tools. But in the vast majority of cases, you really can solve these problems just by looking at that Wi-Fi scanner, seeing, is my signal strong enough for my APs? Are there other APs that might be causing co-channel interference in a given area? Just with that information, you can typically solve most troubleshooting problems, do most preventative validations, do most site surveys. That's been my experience with it. It's really become, the Wi-Fi scanners have really become kind of the number one troubleshooting tool. That said, there may be cases where you want to do some traffic analysis. If you did get a chance to look at my blog post this morning, it's all about using a protocol analyzer. It's all about doing a capture, opening that capture in Wireshark. Wireshark's a popular free protocol analyzer. So sometimes to get more detailed information to do a traffic analysis, protocol analyzer may be necessary. And then another popular tool for troubleshooting is a spectrum analyzer. That's just a real simple thing. If you think non-802.11 interference is an issue, there have been times where everything sort of looks good with the Wi-Fi, but people aren't getting the performance we expect. And when you turn on a spectrum analyzer, you see some non-Wi-Fi interference source that's really causing you a problem. That's the whole key thing with spectrum analyzers, is they're able to see non-Wi-Fi spectrum activity. And so these two things are definitely valuable. The site survey applications, definitely valuable as well, for certain things. But the Wi-Fi scanner is definitely my tool of choice for the surveying, for the preventative validations, and for the troubleshooting in most situations. Yes, Alan, maybe another day I'll be able to go for 2 hours. I'm actually late to something right now, so I really do have to wrap it up. I appreciate very much you all sticking around for this very verbose session here. Yeah, I'm seeing it's 11:30 Pacific time, so I'm really running late. I am already supposed to be on to my next thing. So I got to wrap it up here. But yeah, tune in next week. Next week, at least my plan for now is that I'm going to talk about the wasted Wi-Fi thing that I just blogged about today. So if you do want to, kind of take a look at that blog that I wrote today, again, the blog is at sniffwifi.com. So if you are planning to join me next week, you can get a flavor for what I'm talking about with wasted Wi-Fi by taking a look at that blog. And then, as always, if you have a Twitter suggestion, if there's something that's Wi-Fi related that you're interested in, that you'd like me to talk about, thank you for sticking around, Alan. Much appreciated. Please do feel free to tweet me. I'm always open to talking about different topics. We talked about a topic a few weeks ago about upgrading from Wi-Fi 4 or from Wi-Fi 5 to Wi-Fi 6, and how that might affect your site serving. That's a topic that I got from Twitter. If you have a Wi-Fi topic, feel free to check it out. All right, got to sign off for now. I know, looking at the clock, I already have some people very mad at me. But hopefully you all enjoyed it. And I'll see you next week, 10 a.m. Pacific time. Have a good one.